All right, so this video is a two-part video, okay? In the first video, we're going to talk about some vocabulary words, and we're going to look at the exponential graph, okay? And we're going to do some key features with it. You know some of these vocabulary words because we talked about them with absolute values, but today we're going to extend it to exponentials and add a few more words, all right? So, vocabulary. An asymptote, we're going to start with a brand new word, okay? An asymptote is an imaginary line that the graph approaches but will not cross. Now this asymptote is extremely important because it tells you what kind of function you have, okay? By looking at where this graph is like flatlining. Now these graphs aren't as, the graphs I'm going to give you are a little bit different because you can tell the flat line a little better because these were hand drawn. So if you look, exponential function, it's going to curve and it's going to go super flat and it's going to get really close to that asymptote. Okay, so an exponential function has a horizontal asymptote. So this is a horizontal asymptote. Okay, and that's what an exponential has, and it's going to be of the y equals function. Your logarithmic function has a vertical asymptote that goes up and down. Okay, and it's going to be an x equals function. And I'm going to show you when we get to the examples how you can tell where your asymptote is by looking at the graph, okay? Because it's going to approach it, but it's not going to cross it with an exponential and a logarithmic function. All right, next, we've talked about domain and range in here before. We're going to redo it. Your domain is how wide is your function, okay? So domain tells you how wide you are from left to right, okay? It's left to right, just like you read a book, okay? That is your domain. It is your x values. Now, your range is going to be how tall your function is, but it goes from low to high, okay? All right, next we're going to talk about increasing and decreasing. They're new math vocabulary words for you, but they're not new like words for you. So increasing function means basically that if I trace my function, am I going up or am I going down? So if I trace this function with my highlighter, look, am I going up? I'm chugging along up. So that means this graph's increasing. Same here, and it's left to right, just like you read a book. So if you look here, I'm chugging along and I'm going up, right? So that is an increasing function, okay? Next, a decreasing function, you do the same thing. You take your pen, you highlight it. How are we going? Well, we're going downhill on this, so that means that this is a decreasing function. Same here. I'm going down, decreasing function. I almost sang a song. All right, next. X-intercept, we've talked about this. It's where the graph intersects the x-axis. It intersects the x-axis. My bad, guys. X-axis is right here, and that would be my x-intercept. All right. Your y-intercept is where you cross the y-axis, okay? All right, so that is it for vocabulary words. Now we're going to look at exponential functions, and we're going to do some key features. But before we do that, I need you to understand how can you tell that it's an exponential function. You can tell by the equation, and you can tell by the graph, okay? And my graph one's a little cheat, I feel like, but it'll help you out. So an exponential function. An exponential function is all of this on this screen. What all of this means is you have an exponential in the form of y. We're going to get the pen back. And y equals a times b to the x, where a is your initial starting amount. So if a was 2 and we were talking about money, you would say you started with $2. Okay? B is going to be your growth factor. We're going to get more into that when we get to the application section here. Okay, so don't worry too much about that. And along with A, what you really need to know that is, how do you know it's an exponential function? By looking at the equation. Because the variable is the exponent. If the variable is the exponent, then it is an exponential function. Okay, that is what you need to know. So if we go to this next slide, I want to know which one of these is an exponential function. Okay, well, if you look at number 1, we're going to label these 1, 2, and 3. 1. How do I know if that's an exponential or not? Is the variable your exponent? Well, yes, my variable is my exponent. It's right there. So this one is an exponential. Number 2. Now, I know variables are letters, but we all know that pi, yes, it's a Greek letter, but it also represents a number. 3.14, blah, 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 blah. Okay? But it's still a number. So therefore, number 2 is not an exponential function because pi is a number. Now, number 3, is number 3 an exponential? No, because there is not an x up there in that exponent, and because because the base is not a constant. So your base can't be a variable either. Okay, the exponent has to be the variable. Nobody else can be. Okay? All right, so now let's get into some key features. All right, we're going to do 4 examples, and then we're going to call it for this video. All right? So, how do you know this is exponential? There are 2 ways I know this is exponential. One we just talked about, and the first way is, look right there. My exponent is my variable, right? So since my variable is my exponent, that means it's an exponential. We're going to write that because I want you to write it on your classwork looks just like this. Because my variable is the exponent. Now, this is what I'm talking about with the asymptote, okay? So we're going to answer this question along with answering 4 and 5, okay? So if you look, you want to see where your graph is flatlining. Where does it look like it's going straight in a line? It doesn't look like it's going wide anymore. It doesn't look like it's switching lanes. It looks like it's going on a straight line, no detour, no left turn, no swerving, okay? And if you look, my graph is flat right here. Do we agree? Do you see how it's flat horizontally? Since it is flat horizontally, that means that it's an exponential because my asymptote is horizontal. Because asymptote, whoops, I don't know where my M went. Okay, because my asymptote is horizontal. Now, I'm going to flash forward so I can show you. It's always good when we have a comparing option going on. So I'm going to flash forward real fast to here. No, to here so you can see it good. All right, where does it seem like this graph starts going straight? No curves, no detours, no left turns, no swerving. It ain't horizontal, is it? Because it looks like that one's swerving on up, right? But if you look down here, you see how it's flatlining down here? But it's flatlining vertically, and that's why that one's a logarithmic, okay? And it's probably not scientific, and I'm telling you this, but it helps me out, and so I'm trying to help you guys out, okay? So I have a horizontal asymptote here, so I can go ahead and circle horizontal, okay? Now, since this is horizontal, a horizontal equation goes through the y-axis, so it's a y equals formula. So this is going to be y equals, where is this flatlining at? -6, okay? All right, x-intercept and y-intercept, we are going to guesstimate these as best we can. Now, you always can, which is what I do. If it gives me the equation and I'm struggling trying to find it, what I do is I type this equation into Desmos, and it gives me that click point. So I don't have to worry about getting it wrong or guesstimating it wrong, okay? So all I do is when I type this into Desmos right here, just click on the point that where it crosses the x-intercept, okay? And when I did Desmos on this one and I found this x-intercept right here, when I clicked the point, my x-intercept was -2.5850, okay? Just don't forget about Desmos. It's a very good tool to use. Now this one, you can tell you don't really need it, but you could if you want to. But my y-intercept, so this is my y-intercept. And this was my x. My y-intercept is going to be 0, -5. All right. Now, next, increasing or decreasing. This is when we take our highlighter and we see if we're going down or are we going up. So start from left, go to right. Am I going down or am I going up? I'm going down. So that means that this function is decreasing. Uh-oh. It is decreasing. Okay? All right, my range. My range is how low do you go to how high do you go? Well, do I go any lower than -6 here? No, because the asymptote is kind of like a barrier. It's saying you can't go past it. So you're not going to go any lower than that number, or any higher than that number, or to the left anymore, or to the right anymore. Okay? So my range is as low as -6. And then what is this arrow pointing up telling me? It's telling me I'm going off the charts to positive infinity. Okay? Now, domain, I'm going to let you know in a little secret here, that domain for an exponential, we'll say it again, the domain for the exponential function is -infinity to positive infinity. Always. Okay? Always for us, this is true. Okay? So go ahead and get on your on the assignment, and for domain, it needs to be the same answer for everything. Okay? All right. So let's do another one. All right, here's another one. Now, how do you know that this one's exponential? Again, x is my exponent. So the variable is the exponent. Okay? Also, find that asymptote. Is this asymptote vertical or is it horizontal? Where are you flatlining? Well, I'm going straight right here again at -6. So that means that since my asymptote is horizontal, I am exponential. Okay? All right. Now, so my asymptote is horizontal, which is a y equals, so it's y equals -6. Now, not all asymptotes are -6. It just happens that these two were -6. Okay? All right, so next, x-intercept. Again, I would type these into Desmos because Desmos gives you that click point, which is really nice to have. Okay, it kind of takes the edge off a little of these questions. Okay, so the x-intercept here, this is your x-intercept, and when I type this one into Desmos, I got 1.6310. The y-intercept, again, is 0, -5. Okay? Now, is this one increasing or decreasing? You're going from left to right. Are you going uphill or are you going downhill? So from the left to the right, I'm chugging along up that hill. So I'm increasing here. Okay? I already told you, I gave you the let the cat out of the bag, the secret's out there. Domain is -infinity to positive infinity. Okay? So the range though, how low do you go? So how low does the graph go? It goes as low as -6, and it goes as high as positive infinity. Okay? All right, let's go on to the next one. All right, so this one, same questions, different graph. Okay? So how do you know it's exponential? The x is the exponent. So the variable is the exponent. Okay? Also, find the asymptote, okay? Find the asymptote. Is that asymptote horizontal or is it vertical? Where are we driving straight? We are driving straight right here. Thank goodness it won't -6, because then y'all really wouldn't believe me. So if you look right here, we are going horizontal at 6. Okay, so we're going horizontal at 6, so that means it's exponential because my asymptote is horizontal. Okay? All right, x and y intercept. Again, I say it over and over again because hopefully y'all will listen to me. Okay? And I'm typing the equation into Desmos, I can't lie. So, I'm typing this into Desmos to find the x and y intercept. Okay? So, my So I typed it wrong. I forgot the negative. So my x-intercept here, when I click it, it's right here. It is at -1, 0. Your x-intercept, your y-intercept, right here at 0, 4. Okay? Use Desmos. Okay? Use Desmos. All right? Next, is it increasing or is it decreasing? Well, if I take my highlighter, am I going uphill or am I going downhill? Well, I'm chugging along up, aren't I? So that means I am increasing. Increasing means up. I've already told you domain is -infinity to +infinity. Now, this graph's been flipped, right? It's not like the other graphs we did. So how low does this graph go? Well, what is this arrow pointing to down here mathematically? What numbers are down there? -infinity. And then how high does this graph go? Where does it stop? It's going to stop at this line right here that's at 6. So it's -infinity to +6. Okay? All right. Last one. All right. How do I know it's exponential? New graph, same answer. Okay? My x. Now the reason I want you to know this is because you are going to have an assignment after both these videos where you have to determine, I give you graphs and you have to tell me if it's log or exponential. So that's why you need to know this. I know it's repetitive because you're like, duh, this is the video on exponentials, so it's exponentials. But when you get to your assignment in a couple of days where it's going to have a mixture of these problems, you need to know. Okay? So my variable is my exponent. Where is it flatlining? It is flatlining horizontally at -1. So it's flatlining horizontally at -1. So my asymptote is horizontal. All right, again, I'm going to type this into Desmos, and it's going to tell me my x and y intercepts. 1/3 raised to the x power -1. I get, well, I really need to do this one, did I? I bet you're at home saying, why is she doing this? Because the obvious that the x and y intercept is 0, 0. All right. Now, is this increasing or is this decreasing? Take my highlighter. I trace it from left to right. Am I going down or am I going up? I'm going down. So that means it is decreasing. Okay? All right, again, domain, -infinity to +infinity. That should be the first thing you fill out, in my opinion, on this example, on this assignment. Now, range. How low does this graph go? Well, this graph goes as low as -1, and it goes off the charts to +infinity. Okay? All right, so that is it for these examples. Let me know if you have any questions or need more help. All right, guys.